chapter 6. Okay. Any questions on that? So chapter 6, all the chapters up until this point have been pretty much one large concept per chapter. Some of them I split into multiple pieces because there were 2 large concepts or something like that. This chapter is a lot of little concepts. This is everything you could possibly ever want to know about objects and methods that wasn't talked about in chapter 5. So chapter 5 talked about here's how you create methods, here's how you might use methods, and here's how we group them together into classes, here's how we use classes to represent real-world things, here's how we use classes, create objects with them, and that sort of thing. Here's all the other little things that you can do with classes. So this class will be kind of a slightly different structure from all the previous classes. All the previous classes have been me doing an example, and as I go through building on the topic, I'm going to start by going through every little section of this chapter, and then we'll try to put it all together with a big example at the end. Sound like a plan? Okay. I think this chapter actually has the most sections of any chapter in the book, but they're all pretty short. The first concept is constructors. And we've seen this already from the calling side. A constructor is basically a method that creates an instance of an object in a very special way. It follows very special rules. So we've seen the new keyword before. Scanner keyword equals new scanner system.in. Using that new keyword basically means we want to use a constructor. And that's exactly what scanner parentheses system.in is. It is a constructor for the scanner class. It happens to take one parameter because constructors are a specialized case of a method. So they take parameters, they take arguments, depending on whether you're declaring or using. But what's odd about them is that they do not have a return type because they are a special case of method. The method name is identical to the name of the class, and that's how you tell Java this is a constructor. So 2 important things. The method name is exactly the same as the name of the class. So if you're writing a car class, like you are for the programming assignment that's due today. Reminder, exam also due today. I've received a few exams already. So make sure to get those in on time. I don't want to deal with collecting any of them late because that's just too much of a hassle. There's only one of them. So for this car class, to create a constructor for it, you create a method with the name car. Capitalization exactly the same. Spelling exactly the same. Does not have a return type. That's item number 2 on constructors. Because the way these constructors actually work is Java automatically returns a reference to the object it's created. So you don't have to worry about that. Java just takes care of that. It wouldn't make sense to... There's really no type in Java that represents reference to an object. It just doesn't exist. So for a constructor, the declaration is something like visibility modifier, so usually public, the name of the class, and then parentheses marking what type of parameters it takes. Now you can have what's called a no arguments constructor, which doesn't take any arguments. And if you don't specify a constructor, Java automatically gives that to you. If you don't specify a constructor, you might want to create instances of this object, so Java just kind of gives that to you for free. However, if you specify your own constructor, whether it takes arguments or not, Java automatically doesn't provide that for you. So, like any other method, a constructor can take 0 arguments, it can take 1 argument, it can take multiple arguments. And like other methods, if you specify a constructor as taking 3 arguments, whenever you call that constructor, you have to give it 3 arguments. You don't get a choice on that. Java doesn't have any optional arguments. There are some other languages that you can specify optional arguments. Java doesn't follow that because Java actually has a very different way of handling something similar, which we get to later on in the chapter. What can you do inside of a constructor? Pretty much anything you can do anywhere else. You can call other methods, other instance methods on this class. You can call static methods. You can call system.out.println. You can even call other constructors, which is another use case of this keyword that we saw when we were assigning variables with the same name from inside a method to the class level version of the variable. And this, followed by 2 parentheses, possibly with something in between, is just a call to another constructor. Be careful about that. It is possible to create an infinite construction loop. So if you're in a constructor that takes 1 argument, don't call this with 1 thing in the parentheses, because it'll just call that constructor, which will call that constructor again, call that constructor again. That's bad. You don't want to do that. Another thing that's generally bad to do is doing things that might cause your program to break within constructors. It's generally bad practice. We've seen this before, kind of. These are called exceptions. That's when Java explodes and red text comes up that shows the giant backtrace of where the program actually failed. It's generally bad to do something that intentionally might cause that to occur. If that happens and you're not expecting it, that's okay. You can't program to every possibility. But in general, it's bad to have things break in the constructor. Any questions on constructors? Again, I'll do a big example with all of this at the end. New is a keyword that indicates that you're calling a constructor.
So when you go like species, species, that's a constructor. New is just pointing out that it's a constructor because you're saying species equals new species.
Right. That's an example of using the constructor, not defining the constructor.
Okay.
Yes.
Yeah, I wasn't sure how to define a constructor.
Okay, so yeah, I just finished explaining that. I will give an example at the end. So the second thing that this chapter talks about is something called static variables and methods. So far, what was the example I did last class? What class did I create? I don't remember. I created a dog.
Yeah.
Okay. So everything in dog I referred to as an instance variable and an instance method. That meant that I had to create a dog before I could call any of the methods or use any of those variables. And that meant that all of those variables and all of those methods pertain to a very specific instance of dog. The instance and the methods were tied together. They were inseparable. I couldn't do anything without having an instance of dog. However, you can create variables and methods that don't need a particular instance of a class. Named constants are a good example that we've already seen where this is the case. A named constant is never, ever, ever going to change. It doesn't matter how many instances of these classes that I create. And the one difference, the notable difference between how we've defined named constants and every other variable we've defined in this class is the keyword static. What that keyword static means is that it's associated with the class, with the definition, not with any particular instance. So as soon as we write a Java program, we have access to that variable. And we can do the same thing with methods. trying to think of things that we've. So in the syntax system.out.println and system.in, system is the name of a class. Out and in are names of static variables. Sometimes they're referred to as class variables because they're tied to the class, not to a specific object, not to an instance. These are static variables that we don't have to create an instance of system. I don't even know that you can create an instance of system. It's really not meaningful. And you immediately have access to them. They are basically properties of the class as opposed to properties of a specific instance of that class. And I'll do an example of that at the end as well. We can also do that with methods. Trying to think of methods that we've seen that that's the case. I know in the other class we've dealt with methods like that, but I don't know if we've seen any here.
We do public static void every time. But do you have to?
Good call.
Do you have to? Because you can access a class outside of the class. Do you have to declare the static variable within that class definition? Obviously.
Yes. So rule number one with Java. Nothing exists outside of a class definition. It's not possible. Everything must be inside a class. So if it's static, if it's non-static, doesn't matter. It always has to be within class, name of class, curly braces, before that end curly braces. The only thing that we've seen so far that can be outside of that is an import statement, because that really exists outside of a class. That's not saying this thing that I'm using is not somehow inside of this class. This is another class that exists somewhere else. So that's outside of the class.
Does that mean you can't call another method's name? Like I can't use dog name to call dog main method of dog class, right? Because it's static.
So there are some funky rules with that, and I'll get to those in a minute. But first, you had good call on mentioning that main we've been declaring it static. Java doesn't create an instance of the class that has your main method in it and then call main on that instance. That would be inefficient. Java just takes that class, and main is a static method. There's one copy of the main method for all of Java, and it's as simple as let's see. The first program we wrote was called first program. So Java calls first program.main, and that executes that main method, not tied to any instance of first program. At that point, it really didn't make sense to have an instance of first program because there was no substance to it. But it calls that static method, and everything inside that runs as we expect it to. To continue with that, there are some rules as to what you can do in static methods and non-static methods. So, since static methods exist outside of any instance of any class, really, you can't act as if there's an instance of that class. So you can't access instance variables. You can't access non-static variables within the same class because they may or may not exist. And even if they do exist, what instance am I talking about? There is no. It's not tied to a particular instance, so it's really ambiguous. You can't call instance methods, again, for exactly the same reason. However, in instance methods, you can call static methods because it doesn't matter how many instances you have. Those static methods always exist. There's always one copy of them. There's nothing preventing them from existing. There's no ambiguity in figuring out which, I'll call it a resource to group variables and methods together. There's no ambiguity as to what resource you're talking about. There's only one. Does that make sense? Does that answer your question? Okay. And the classic example of this is the math class. There is a class in Java called math, and it has lots of cool things on it. It has a static variable, a constant, a named constant called pi. So you never have to write pi into your programs again. You can just use math.pi.
I have to import it.
You do not need to import math because it is part of the java.lang package. There's E. So if you're dealing with, oh geez, I've forgotten the mathematical definition of E. I know it's 15 decimal places, but believe me, that doesn't help you. My calculus teacher, my senior year of high school, told us at the very beginning of the semester, there will be one exam where you will have to know E to 15 decimal places. The second part of that question was you have to know the mathematical definition of E. I've since forgotten the mathematical definition of E, but I've remembered E to 15 decimal places. And it's stuck. I'm never going to use it, ever, but I'm never going to be able to forget it. 2.718281828459045. I'm a nerd. Okay, moving on. Math class also has several static methods, which are useful. I mentioned one for, I think it was programming assignment 2, when we were dealing with radius and stuff like that. I conveniently didn't mention math.pi at that time, because I wanted to see that you guys understood named constants. But there's a method called pow, which takes two arguments, a base and an exponent, and raises the base to that exponent and gives you back a number. There's also a method called Sqrt, which takes the square root of the argument that you give it. And there are a few others, and I think the chapter mentions those. 402, yes. Absolute value, maximum, minimum, random number, rounding, ceiling, floor, and the other two that I talked about. There are plenty more. You can look in the documentation and see what all the math class provides. And this brings up sort of a philosophical distinction. There are some classes that either we can write or we can find in the Java framework that are intended as Java representations of real-world things. How real-world they can be is debatable, but like scanner, how real-world is that? But things that are intended for us to create instances of. There are also things in Java and things that we can write ourselves that are classes for the purpose of grouping methods together, grouping common operations together. And that's what the math class is. Square root, pow, min, max, absolute value, all of those things are fairly simple and common operations that we want to do. But in Java, everything has to be inside a class. And it really doesn't make sense, but thankfully, whoever wrote this didn't force us to create an instance of math number converter class just so we could use all these methods. They're all static methods. We can use them. We don't have to create an instance of anything. They're just there available for us to use. We can think of these kind of like subroutines that are just available. Just call off them. And the other instance, the other case that the book mentions where static methods are useful is, I've already mentioned top-down programming, correct? So if you don't want to create a class, you don't want to create instance methods, you can still create static methods that your main method calls off to. So this would be multiple methods in the same class. All of them are static. Each one of them does a small piece of the bigger problem. If it doesn't make sense to create an instance just to use a piece of functionality, you can create a static method. Yes. And so the main reason you can have general methods be private. And that makes sense in terms of pretty much the only reasoning for doing that is there's a piece of functionality that you want to break off into its own chunk. It could be because you want to think about the problem in a smaller context, think about a very specific problem and solve that problem without having to deal with the rest of the problem. There might also be a piece of code that either you can come at it from multiple directions. You can start out copying and pasting it a lot of times, then realize that you've copied and pasted it a lot of times and it would be better suited to put in a method. Or you can write the method first, and because you know you're going to use that functionality over and over again. So in that case, you'd have a private method, regardless of whether it's static or non-static, an instance method, depending on where you're using it. And those are referred to as helper methods.
That's what I was thinking of. So your main method on that would be public, private.
Right. So the basic rule of thumb between public and private is if things outside of the class are supposed to be able to see it, it should be public. If nothing outside of the class should be able to see it, it should be private. And in general, I find it helpful to start out by making everything private. And then if I know I'm going to need it from somewhere else, then I'll make it public. Because that limits the damage that I'm able to do. You know, if you make everything public to begin with, then who knows what someone's going to do. Who knows what you're going to do. It especially helps when you write something and come back to it in 3 months, don't remember how you did something. At least you have the public interface and know how you intended yourself to use it. There are also classes that are have a combination of static methods, instance methods, static things, and static behaviors, and instance behaviors. The most common examples of these are something called the wrapper classes. Because Java is very object-oriented, for a while it was very irritating when you didn't need an object. You didn't need the overhead of an object. So you were storing something like a character or an int. And a lot of things in Java work very well on objects and don't work very well on primitive types. So finally, Sun decided that they would implement these things called wrapper classes. And now, just recently, I think with 1.6, the version of Java that I have, 2 versions ago from the version of Java that you guys have on these machines, these wrapper classes and the primitive types can be converted between each other just automatically. Sometimes this is referred to as boxing and unboxing. The idea being that you have a primitive type, a value of a primitive type, and you stick it in one of these wrapper classes, and it's kind of like packing it into a box. And then when you want to get the value back, you unbox it. You open the box and take the value out. So in this case, these classes can be specific instances. They have a specific value, a character C. I think the big example that they use in the book is the character class. And at the top of page 405, you can see this conversion between an instance of the character class and a variable of type char. And that works. Because these classes represent, it's kind of adaptive functionality. It's, oops, we didn't think as far ahead as we probably should have. Here's a way to fix that. So there are a bunch of static methods on these classes. So you can call character dot some method and do some stuff with characters. Some things are converting between the object and the primitive type. I think you can convert from strings to arrays of characters, that sort of thing. Actually, I think that's on the string class. But there are a lot of cool things you can do. 2 uppercase, 2 lowercase, is uppercase, is lowercase on the character class. And the examples that the book gives are mainly methods that need to go somewhere, just like all the methods in the math class, that operate on variables of type char. Because primitive types are not objects, so they can't have methods. But objects or classes that have a bunch of static methods, they can have methods because they do. And so that's where all those methods exist. The book kind of sticks section 6.3 in the middle of this chapter. It's useful stuff, but not really pertinent to objects and methods. If you haven't already read that section, I definitely recommend reading that section, because there's helpful stuff in there, just not critical. So the next two, or the other two topics I'm going to cover today are 6.4 and 6.7, overloading in packages. I've pretty much already discussed 6.5 with our discussion of public and private, and my strategy of make everything private and then only what I need to make it public. And that's what they talk about in terms of privacy leaks. If something really shouldn't have access to something, make sure it really doesn't have access to something. So, overloading. Before I mentioned that Java does not have optional arguments. However, you can implement multiple methods with the exact same name that take different number of arguments. So if you want to have a method that takes 3 arguments but the third one is optional, you would actually write 2 methods, both with the same name, one that takes 2 arguments, one that takes 3 arguments. And what that does is Java does something called late binding. It tests to make sure that the appropriate method exists at 2 different times. Once at compile time to make sure your program's not going to blow up in your face, or have a reasonable guarantee of that, as much as it can at compile time. And once at runtime, when you call a method with 3 arguments, it says, okay, where's this method with 3 arguments? And when it finds it, it executes. If it can't find it at runtime, it really, really blows up. Which is possible to do. You can compile something, have it compile fine, run it, and have it blow up. I don't recommend trying to do that. I really don't recommend trying to do that. Don't do that. Okay. And that's basically overloading. There's really not much to overloading. It's kind of nuanced, but the essence of it is that you have multiple methods. It doesn't have to be 2. It can be more than 2. In some places in the Java framework, there are methods that are overloaded as many as 7 or 8 times. The documentation gets confusing, but the key point is all the methods, when you're overloading a method, all of those methods have the same name. They have different numbers and types of arguments. You cannot have 2 methods with the same number. You cannot have 2 methods with the same name that take the same number of arguments, just different types of arguments. That doesn't work. Java gets confused. There's no restriction as to what these methods can return. If you return a Boolean from one of these methods, you can return a string from another one. Java does not look at the return type to figure out which of these methods to use. It only looks at name and number of arguments. And it looks at type as well to make sure that these are valid types that can be put into these methods. One of the most common places for this is in constructors. For instance, you might have a no arguments constructor, be it public or private, depending on whether or not you want other people to be able to use this, that does some initialization. That is necessary no matter what other initialization you're doing to this class. You might be storing an instance variable that no matter what you're doing always needs to be initialized to the value 5. Don't ask me why, you just want it to be initialized to the value 5. But it's not something that the user is ever going to see, or when I say user, I mean the user of this class. Not something that the rest of your code will ever see, not something that you want to be able to pass in through a constructor, but it should always start out with a value 5. But you still want to have other constructors that take varying number of arguments. So rather than copying and pasting my variable equals 5 into every single constructor, because who knows, down the road you might have another variable called my second variable and you want to initialize that to the value 7. You don't want to copy and paste that to every constructor and hope you got all the constructors. You want to put all of that in a single constructor, and then from all the other constructors, call that constructor, which can be accomplished using the this keyword. You just say this, 2 parentheses, don't pass anything else in, and it will call that other constructor. And that's an instance of overloading, because every single constructor must have the same name in order to have in order for it to be a constructor. If you have multiple constructors, they must take different number of arguments. And since constructors don't have a return value, it doesn't really matter if they have the same return value or not. They don't have a return value, so that point is moot. Any question on overloading? In theory, anyway. The final topic of this chapter is packages. And packages are something that we've seen to a certain extent already. When we use a scanner, we import java.util.scanner. That import directive specifies the package and the class name that we're using. The package is everything before the class name. So in that case, java.util. A package is simply a broader level of collecting things together. So while some classes, like the math class, are used to collect a bunch of methods together, packages are used to collect a bunch of classes together into some logical order. And that's really what makes the Java framework a framework. It's not just a bunch of classes thrown together. It's a bunch of classes thrown together with some organization. So we've seen things in java.util. Everything that we don't have to add an import statement for, we don't have to add an import statement for it. Everything in java.lang is automatically available to us. So system, math, those are the 2 I can think of off the top of my head. But there are a whole bunch of others. And we can actually create our own packages, though some really funky rules go along with that. Java expects that if we have a package called myPackage, all of the source files that are in package myPackage exist in a directory called myPackage. Really overkill for the programs that we're writing. If you start building more expansive and complicated programs, packages are definitely helpful. But the baggage that comes along with that is that you do have to create this directory structure. And at that point, you're probably using an IDE, an integrated development environment, that automatically builds these packages for you. These computers have NetBeans installed on them. That's the IDE I use, but it's overkill for what we're doing here. So things that are not so Java looks 2 places for classes that you use. it looks in java.lang, and it looks in the current directory. So right next to the Java file you're running. If you want to use something that's not in either of those places, you have to specify an import statement. So if you want to use scanner, you import java.util.scanner. On the flip side, if you want to put a class in a package, there is a keyword called package, and that's the only other thing that can go outside of a class definition. You have import statements, then you have package, the name of the package that this class is a part of, and then your class definition. But again, if you have a package directive in your Java class, you need to do some additional work to make sure it's in the proper directory that Java is going to look in. So for ease of writing Java programs, don't bother putting a package in there. Don't say your class is part of a package. This will make it part of what's called the default package, which is basically the universe. So I never thought the Mac desktop background would come in handy, but imagine this is all of Java. Let me turn on the lights. This is all of Java. Each individual star is a specific package. If you specify that your class is inside a package, it's part of one of those stars. If you don't specify it's part of that package, it's kind of floating around here with everything else. For now, it's a lot easier just to have everything floating around with everything else. Does anyone have any questions on the material before we jump into an example? So, let's see. For my example class, I'm going to create a class called throttle. I don't really care if it's on an airplane or a boat, but that's the sort of throttle we're going with. So as previously mentioned, that's the beginning of my throttle class. That is the simplest possible class that I could write, though it doesn't do a whole lot. And quick note about where your main method can go. Any class can have a main method. I feel like I've mentioned this before. Any class can have a main method. But not all classes have to have a main method. In the assignment that's due today, I asked that there be a main method in the car class, just because it's easier. You write one class, you can run it, you can compile it and run it, don't have to do anything fancy. I will write a separate class that will end up being called carmain.java that will have a main method, and that's the class that I will run.
So in the homework, you want us to add a main in there?
There should be a main method in your car class.
Okay.
The main reason for that,
Public static void main.
Yep.
During all this type of stuff,
following exactly the same rules
and then
that,
methods, right?
and then everything else that pertains to car. The reason for that is because, so at the beginning of the semester I said, if your program does not compile, I give you 25 points and that's it, I don't look at your program anymore. If your program crashes when it runs on valid input, though I've been kind of lax on this, there are certain crashes which I know might happen, so I don't follow this rule. But if I give your program valid input and it crashes horribly, I give you 40 points and I stop looking at it. I recommend compiling your program, Nobody's had an issue with that this semester. Compiling your program to make sure it compiles, and running your program somehow. So I don't specify what you should do in the main method in programming assignment
It just says so you can test.
4.
Including means that you can test.
Right, so that you can test your program. So you make sure that it does what it's supposed to do, and when you call some of the methods, it doesn't break horribly. Basically, so you can hopefully guarantee that you will get more than 40 points. So I don't specify what you have to do inside this main method, but I recommend testing your program. And there's been some discussion in the book about how to test bits and pieces. I think that was in section 6.3, about here's printing useful stuff out so you know that your program works, so that you know that this class does what it's supposed to do. Basically, the purpose is that you can be reasonably confident that when I test your program, it'll work and you'll get points. So I'm going to start by doing that. And there is actually a formal name to writing the code that tests your program before you write your program. That's called test-driven design. It's gained a lot of popularity recently. Further formalization of this. But right now I'm going to write a main method that uses a throttle, and then I'll build functionality and test it along the way. So I'm going to compile my program at this point and make sure it compiles. It's always a good idea to compile like they vote in Chicago, early and often. So you write a piece of code, immediately compile, make sure it still compiles. Write a little bit more code, immediately compile. And in theory, run as well. But sometimes what you're writing is so short that it will compile, it's valid, but it doesn't do something that is meaningful to test. So at this point, this program isn't going to do anything, so it's not meaningful to test, so I'm not going to run. Yes?
Why do not like me to call? I have my own method,
Catch me after class, and I'll look at your... Okay? The reason I say that is because there are a lot of compiler errors in Java. And to go into you could write a book about the compiler. Someone probably has written a book about the compiler errors in Java. But no one would ever want to read it. That's how you know it's a reference. So throttle. Oh geez. Oh, throttle. So here's that new keyword and a call to a constructor. I'm creating an instance of throttle. But notice that I have not specifically declared a constructor. This is using that noargs constructor that Java automatically provides for us. And it compiles, and I'm not going to run it because it still doesn't do anything interesting. Let's create a constructor. And as an example, I'm going to do something kind of, I don't want to say abnormal, but not run-of-the-mill. It's not the easiest thing to do, or not the default way to do things. I'm going to create a private noargs constructor, basically because I do want to do some initialization for every throttle that gets created, no matter what constructor gets called. So I'll end up calling that from other constructors. But I don't want anything else to create a throttle without specifying some parameters. So I'm also going to create some instance variables. So I'm creating two instance variables. One's called throttle max, which will represent the maximum value of the throttle. So some throttles go from 0 to 10, some go from 0 to 100. Some don't have any numbers at all, so this is kind of arbitrary. And I'm also going to I've created an instance variable that represents the current value of the throttle. So if it's at 5 and my throttle max is 100, I'm basically idling. If throttle max is 10 and I'm at 9, that's pretty close to wide open. So the relative values of these variables will determine, in theory, how fast I'm going. So here's my private no-args constructor. Notice it has a visibility modifier. It does not have a return value. Its name is exactly the same as the name of the class. Since it's a no-args constructor, it doesn't take any arguments. And the bit of initialization that I'm going to do here is the fairly intuitive set throttle value to 0. Java has the nice property that when you create a variable, it automatically initializes it. So this statement isn't really necessary. In fact, this statement isn't really meaningful because if your throttle is at 0, it becomes very difficult to start an engine. There's no gas going to the engine. It's not going to start. So let's say that throttle value should probably start out at 1. That way I can start the engine. There's a little bit of gas that'll get let through. And that'll also make this statement meaningful. Because Java is not going to automatically initialize my variables to 1, I might as well do it in my initialization constructor. But I don't want anyone to actually be able to use that constructor. I want to use that for my own personal use, so it's private. However, the way that I do want people to create throttles is by specifying the maximum value. And here what I'll do is set throttle max to max value. So at this point, when I hit compile, what is going to happen? Ideally, it would not compile. However, because I have the main inside the throttle class, it will actually compile.
So if you didn't have the main,
If I had the main in a separate class, which is usually the convention, main is in its own class, and then everything else that does the heavy lifting in your program is in some other classes. Because of the private throttle, it wouldn't be able to see that constructor. However, since everything is all in the same class, it can still see the private constructor, and so it compiles fine. I also failed at the thing I intended to do. The first thing I do inside my constructors that take arguments is call the constructor that doesn't take any arguments, because no matter what constructor actually gets called, I want to do this initialization. So we'll add line 11 in there. And we will also change this to be a valid test. Let's say this throttle goes from 0 to 10. Wrong button. Okay. It still compiles. At this point, and this is another one of my recommendations, before you write anything else, write a toString method. That way you can test the class you're writing as you go along. And what are the 4 things that I mentioned in order to make a valid toString method? First, so of course I can't type in the order that these rules come, but the name of the method is toString. It does not take any arguments. That's rule 3. Rule 2 is it returns a string. And rule 4 is that it does not print anything inside the body of toString. Rule number 5, everything must be spelled correctly. So for this throttle class, right now it has a max and a value. Those might be good things to print out. Whenever I say print out in the context of toString, I don't mean print out, I mean return. It's really up to you what you return. I have picked a convention and I try to stick to it. That's the important part. Let's say we'll print the value and the max. And we'll actually make this meaningful, not string. This is not a string, this is a throttle. That's the extent of my toString method. And let's actually use it. Remember that you don't actually have to call toString. Java takes care of that when you print out. Basically, this is calling the println method on an object. And inside Java's definition of println on an object, it says call the object's toString method. And that's what it actually prints out. So you don't have to actually call toString. As long as you pass an object there, Java will know what to do. And at this point, it is meaningful to run this. Once it makes out, there we go. And it prints out a throttle that has a current value of 1 and a max value of 10. Questions so far?
value in
Run that by me again.
okay, in main, you put your throttle max,
Uh-huh.
you print out your turn line.
Yep.
Why is the throttle 10 maxed off with the maximum throttle?
So in line 20, I call the only constructor that I can actually call, or in theory, that specifies the max value for the throttle. If we look at the definition of that constructor, which is lines 10 through 13, it takes in a value, a single argument, it calls it max value, and it assigns that value to throttle max. So that's how the throttle gets the max value.
So how does it take new throttle value and put a throttle max?
That's the mechanics of calling a constructor.
How do you transfer? Why is both why do they call
So if I do system.out.println and pass in an instance of an object, Java will automatically call its toString method and replace that with whatever toString returns. So
because it's not calling the variable.
right, it's basically equivalent to if I can spell, equivalent to that, but that's redundant. You don't actually have to call toString. Java knows to do that automatically. It says, this is an object. I don't know how to print an object, but I do know that object has a toString method, and I know how to print out strings. So that's kind of a anthropomorphization of Java. Geez, too many syllables. What else do we want to do? We probably want some way to advance the throttle, change the value of the throttle, find out what the throttle's value is, see if it's on, all sorts of cool things. So let's start by, this is really test-driven design. We write how we want to interact with the throttle, and then we write the implementation to make it do what we want it to do. So let's do something like that. I will print it out after each of those calls. So I wrote this code based on how I want throttle to act, not based on what throttle can actually do right now.
Is that a zero or
Is on. That is an O. A capital O. It follows capital case. So the first letter of the first word is lowercase. The first letter of every other word is capitalized. Same thing in line 30. Shut off. So if I were to compile this program right now, it would fail horribly. It would complain that advance did not exist. It would complain that isOn did not exist. Get value did not exist. Shut off did not exist. And idle did not exist. And we can see that. So let's make these things exist. And I'm going to do something called stubbing, which is basically writing the least amount of code I possibly can and still make it compile. So I'm not worried about functionality right now. I'm worried about making it compile. So public void advance. I'm calling it by itself. I don't need to return anything. And it is taking an int that we'll call how far. There's my method for advance. Because it's a void method, I don't have to return anything to make it compile. What else do we have? Is on. The format is on for a method name implies that it returns a Boolean. It returns a yes or no, a true or false. So we'll stick to that convention. Is on should return a Boolean. And I don't pass anything in, so it shouldn't actually take any arguments. Because it has a return value, I need to return something. True is always a good thing to return for a method that returns Boolean. Again, not worried about it actually making sense, just worried about it compiling. Get value, that's basically, it's basically an accessor for throttle value. So it should return an int. Get value. Doesn't take any arguments. And the go-to int value to return when stubbing methods is 0. Again, doesn't make sense. Boat throttle.shutoff. That doesn't return anything. And doesn't take any arguments either. So we don't need to do anything to stub it out. Same thing with idle. And that should be everything we need to stub out. And we see that it compiles fine. That's a good first step. It should run fine as well. It doesn't give any meaningful output. It doesn't actually do anything. Move my code down. To there? Yeah. And sort of homework hint here. If you're worried about not knowing how to do something, but you still want it to compile and you still want it to run, this is the way to do it. Make everything stubs. You'll get past the compilation stage, you'll get past the running stage, and then I'll actually look at your code and see what got implemented and what didn't. Though, depending on what you don't implement, it may actually be a better option to make the program compile, force the program to crash at some point, and get the 40 points. That's right, I am telling you how to game my system.
Where did shut off to the point?
Line 47. And then I figure shutting off the throttle is something I might want to do with the throttle.
You declare the method.
I did eventually go back and declare the method. I didn't have to do any real work because it appears that it doesn't make sense to have it return a value. There's no reason to have it
You just made
take a value. I just made a void method and open curly brace, close curly brace, done. The name of the game is how can I do the least amount of work and still have it compile and in theory run as well. So now we'll go through the methods one at a time and actually make it do something. So the easiest implementation for the advanced method is simply throttle value plus equals how far. But now we need to do some error checking because it's possible that if my throttle goes from 0 to 10 and I give it 50, my throttle value is now going to be well beyond the maximum value that this throttle can hold, and that just doesn't make sense. So let's provide some checking. If throttle value is now beyond the end, so that's if throttle value is greater than throttle max, let's set throttle value equal to throttle max. I need to get rid of that one. That's what I need. However, in the interest of using those math functions, I want the minimum of the throttle max or the value of the throttle. So let's say throttle. We can get rid of this whole if statement. So throttle max or throttle value equals math dot min throttle max throttle value. Does everyone see what I'm doing there? If my throttle max is 10 and I add 50 to whatever my current throttle value is, it's going to be beyond the end of my throttle. So the minimum of those two values would be the throttle max, which is what I set the throttle value to. On the other hand, if my throttle max is 10, the current value is 2, and I advance it by 2. 4 is the current value of the throttle. The throttle max is 10. I want it to end up being 4, so the minimum of those two is 4. So it works out. To make sure it doesn't go beyond the minimum value, which is 0, I can do basically the reverse. Math.max, and I don't have a throttle min, so I'll just put 0 and throttle value. And that should be right, so we'll try compiling. And it appears to work. So now we'll run it. And let's see what comes out. Does it make sense? Scroll down here. It starts out at 1, I advance it 5, it ends up at 6. Sounds right. I advance it by -4, that should give me 2, and I get 2. I advance it by 10, and that should give it initially 12, which is beyond the end of the throttle, so it should set it to 10. That's exactly what I get. And then everything else has been stubbed out, so I get the default thing. Is on always returns true, I get true. get value always returns 0, I get 0. Idle does absolutely nothing, so it doesn't change anything. So let's move on to the next one. Is on. What does it mean for this throttle to be on? It means that the throttle value is not 0. Well, in this case, it's sufficient to say it's greater than 0. So return throttle value greater than 0. Throttle value greater than 0 is a Boolean expression. It will evaluate to either true or false, so I can return that directly. I don't need to save it somewhere as an intermediate value and then return a variable. And there shouldn't be any issues with that. I'm not setting anything. I don't have to do any error checking. So compile it, make sure it compiles. It does. And let's run it, and the output's going to be exactly the same because it's still going to return true. This throttle is still on. Let's move on to get value. Like I said, this is basically an accessor. So return throttle value. Compile. And now that print statement works. It actually gets the proper value. I didn't actually. Yes, I did. I did test shut off. So, what should shut off do? Should set the value to 0. Make no gas flowing to the engine. So, throttle value. Set that to 0. Don't have to worry about any error checking because I am in control of both values here. While we're at it, let's get ambitious and implement another method. Idle should set it back to that initial state, that 1 value. So throttle value. And now what should change is this number should end up as 0, and this number should end up as 1. And that is, in fact, what happens. Any questions about that?
Can you go down to the bottom of the
Let me slow this down. So now let's play around with some overloading. Let's say instead of idling at 1, I want to idle at 2. So obviously I compile this and it breaks. It says idle that takes an int. Idle in throttle cannot be applied to int. There is no idle that takes an int as an argument. However, if I change this to value and then do that, it'll complain that there is no throttle there is no idle that doesn't take an int. Idle, int, and throttle cannot be applied to no arguments, which means I have to implement two different methods. One that doesn't take any arguments and one that takes an int as an argument. And in this, I've already implemented the one that takes an argument. In the one that doesn't take any arguments, I could make the implementation exactly the same as I had before. Which was that. But now I kind of have repeated code. And this example is arguably contrived, and arguably this could be left as is. This is fine as is. But if there's more complicated code that ends up getting repeated, this would not be fine as is. So we'll pretend that it's not fine as is, and we will call the other idle method from within this idle method, and say idle at 1. And if we compile and run, everything works as expected. And at this point I've given examples of everything that I talked about from this chapter, with the exception of writing static variables and static methods, but we've already had lots of practice doing that. So I will leave that as the common exercise to the reader.
How did you get the 2 in the last one?
I specified it as the argument to idle.
I think that's too, so I'm missing it. I have both of the items. I'll put the item in the item.
Let me scroll up to my implementation of 2 idles. So
I see what it is. I'm missing one of the items. You do volume code. All 3.
So, I ran a little bit over today. We'll take a break, and when we reconvene, you have options. You have an exam that's due at 11:59 tonight, so you're welcome to work on that. You're welcome to ask me questions about that. You're not welcome to ask me what the answer to a question on the exam is. You have a homework assignment, unfortunately, also due at the same time that the exam is. I'm sorry, there really wasn't much I could do about that. You can't do that, because that would interfere with the next assignment. You're right, but I've already written the syllabus, and I stick to the syllabus. So you're welcome to ask me questions about that. That's assignment Q. There's another assignment that's assigned today and due a week from today. If you want to get ahead, you're welcome to work on that, and welcome to ask me questions about that. There's also a very nice example of this stuff, the stuff we just talked about, in the book. It is, what do they call these? Programming Project 9 on page 468. if you're really ambitious and don't have enough to do, you're welcome to work on that. It's a good, the person class is a standard example of this type of stuff. So you're welcome to work through that. Welcome to ask me questions about that. And of course, welcome to ask me questions about just about anything pertaining to the class. So, 10-minute break. Well, it's kind of informal after this. So, if you come back, cool. When you come back, cool.